further trig equations, just doing a few more examples. These are just the examples from exercise 12.2. Okay, so solve from 0 to 2 pi, just looking at a few of these. Example 7a. So first thing we'd need to do is to take this 2 over and divide through by 2. Now remember, we're trying to solve for 0 to 2 pi. So our new domain is, we've got x plus pi on 6 instead of just x. So we have to add, how do we go from x to x plus pi on 6 is we add pi on 6 to the x, so we have to add it to each of these. So 0 plus pi on 6 is pi on 6. And 2 pi plus pi on 6 is 2 1/6, which is 13 pi over 6. So x plus pi on 6 has to lie between pi on 6 and 13 pi over 6. So again, we just follow our same steps once we've got our new domain. So step 1 is the acute angle. But it's not acute angle x, it's acute angle x plus pi on 6. Because we say cos of this is a half. Now cos of what is a half? Cos of 60, which is pi on 3. So the acute angle is pi on 3. Step 2 is to look at the quadrants. So our quadrants, cos is positive. Cos is positive in quadrants 1 and 4. So therefore we've got the acute angle of pi on 3 in quadrants 1 and 4. Please make sure that you do draw a diagram, makes it a lot easier. So therefore x, my solutions for step 3 are that x plus pi on 6 will be the quadrant 1 result, which is pi on 3. Now we've just got to make sure that your result lies within there. Now pi on 3, that's 60 and 60 degrees, and this is 30 degrees pi on 6, so it does lie within this domain. This is like from 30 to 360 to 390, because if that's 360 plus another 30, right? And this is 60 degrees, so 60 degrees does lie between 30 and 390 degrees, and my other angle is here, which is almost 2 pi but short a third, so 2 pi minus a third pi. So therefore x plus pi on 6 is pi on 3, and 2 minus a third, that's 1 2/3, which is 5 pi on 3. And now we just subtract pi on 6 from each of these values. And remember, you're just working with fractions, so really that's a third minus a sixth. So if you put this over 6, it would be 2 pi on 6 minus pi on 6, that's pi on 6. And this is 10 pi on 6 minus pi on 6, which is 9 pi on 6. Now remember, that simplifies to 3 pi on 2. So our two solutions are x is pi on 6 and 3 pi on 2. Notice that those two solutions do fit between 0 and 2 pi. For the next example, 2 sine x minus pi on 4 is equal to negative 3. Again, we're solving. So we're solving that for 0 to 2 pi, just taking that 2 over, dividing through by 2, you would get negative root 3 on 2. We can do quadrants or acute angle. We can say acute angle, but the acute angle is x minus pi on 4, because we say sine of this is root 3 on 2. Remember to ignore the negative, it's just telling me which quadrants we're in. So sine of what is root 3 on 2? That's sine 60. So that's pi on 3. So what haven't I done? I haven't done my new domain. So with my new domain, I must do x minus pi on 4. So we have to subtract pi on 4 from each of these. So we get negative pi on 4 is less than or equal to x minus pi on 4, which is less than or equal to, now 2 pi minus pi on 4, that's 2 minus a quarter. That's 1 3/4, or 7 pi on 4. Okay, so I'm subtracting pi on 4 from each of those. So my acute angle is pi on 3, because sine of 60 is root 3 on 2. And my quadrants, sine is negative. We can see we've got negative in quadrants 3 and 4. So we've got quadrants 3 and 4. So drawing your diagram, pi on 3 is the acute angle in quadrants 3 and 4. And now writing out our solutions. So x minus pi on 4 is the quadrant 3 result. Remember, that's 0, pi, 2 pi. So it's pi plus pi and 3. Now pi plus pi and 3, that's 1 1/3. That's 4 over 3 pi. And this last one is almost 2 pi except for 1/3. So it's 2 minus 1/3 is 1 2/3, which is 5 pi on 3. Just checking that these fit within this domain. So it does. That's a bit more than, well, this is from -45 up to 135. If you're not sure if it fits in, just leave it for now. And what we're going to do now is add pi on 4 to each of these. And as long as so let's say you can't tell whether this fits in there, whether this is smaller than that or not. See, this is 1 3/4, this is 1 2/3, this is smaller than that, so it's fine. But sometimes you might not be sure. But what you can do is, if you find that one of these is not between 0 and 2 pi, so once you get to the end, you're working, x must be between 0 and 2 pi, and that's the ultimate check at the end that it is. So here I've got adding these, so that's 4 over 3 plus 1/4. If you go common denominator, the denominator is going to be 12, and you're going to get 16 plus 3. That's 19 pi on 12. And this one, common denominator again of 12, 23 pi on 12. And that is less than 2 pi, because 24 pi on 12 would be 2 pi. And this is 1 point something pi, so that's fine. So they're your two solutions there. Okay, and now the last one, just done the same way. Look, I probably don't, oh, look, I will do this one. All right, so again, you need to divide by √3. And again, make sure that you are changing your domain. So if you're working with x plus pi and 3, we need to add pi and 3 to each of those, and that's 2 1/3. So we're adding 2 plus 1/3, that's 2 1/3, that's 7 pi on 3. Okay, now, again, your 3 steps. Step 1 is your acute angle, x plus pi and 3. Well, we say tan of what is 1 on √3? It's tan 30, which is pi on 6. And then we look at the quadrants that we're in. So we've got quadrants. Tan is positive. Quadrants. Sorry. So we say tan is positive in quadrants 1 and 3. So we look at our results. So therefore x plus pi and 3 is, so doing a sketch, your acute angle is pi on 6, and we're in quadrants 1 and 3. Okay, now, so x plus pi on 3 is, first result is pi on 6. Now, just be careful here, because pi on 3 is 60, and 7 pi on 3, well, that's 2 pi plus another, well, it's 360 plus another 60, which is 420. Now, my first answer here, or my first result here, is 30 degrees. That's pi on 6 is 30. That is less than 60. So this is actually not a solution. So I'm just going to leave it there for now. So I've got pi on 6, and then I've got pi plus pi on 6. That would be 7 pi on 6. Now, because this is not a solution, I'm just going to put a cross through it for now. Because see, that's only 30 degrees. And it's supposed to be bigger, 60 or more. And then if this is too small this time round, I have to include it next time round. So I've got 2 pi plus pi on 6. So that's 2 1/6, that's 13 pi on 6. So this one is not a solution. But look, what I'll do, I'll just leave it there for now. Right? Let's say you didn't realize it. You would just keep working. Now I need to subtract pi on 3 from each of these, right? And this is what you would get. So you've got, so what I've got, let's say you didn't pick it up here, that it's not a solution. You would end up with pi on 6 minus pi on 3. That's 1/6 minus 1/3. It would be negative pi on 6. Now we can see that that does not lie between 0 and 2 pi. And this would be 7 pi and 6 minus 2 pi and 6. That would be 5 pi and 6. And the next one would be 13 pi and 6. Now pi and 3 is 2 pi and 6, so 13 minus 2. That would be 11 pi and 6. Now we can see that this negative pi and 6 is not a solution. So if you didn't pick it up here, you would pick it up here. And what you'd need to do is just go back and cross that out. But as long as you're crossing it out here, or you can just write, therefore, your solutions are x is 5 pi and 6 and 11 pi and 6, okay? Just making sure that those final two solutions lie between 0 and 2 pi, all right? Just be careful with that type, okay? Question 8, example 8, example 8. Just solving this type. So we did do something similar in class. So sine of 3x, 2 sine 3x is 1. First thing you need to do, we're solving between negative pi and pi. First thing, let's divide by 2. But however, we're solving between negative pi and pi for x. However, we've got 3x, so you need to multiply everything by 3. So therefore, we need to look at our solutions, have to go from 0 to 3 pi and from 0 to negative 3 pi. So what I'm going to do, I'm going to have two separate graphs. One for the positive angles and one for the negative angles. Okay? So, again, step 1, your acute angle. So my acute angle 3x, sine of what is a half? Well, it's sine 30, which is pi and 6. And my quadrant, step 2, sine is, in this case, positive in quadrants 1 and 2. And step 3 is to list my results. So 3x is. Now, I'm going to do positive angles first. I've got quadrants 1 and 2, and my angle is pi and 6. Now, I know I'm drawing it too big, but that's fine. So I've got 0, pi, 2 pi. So on my first time round, I've got pi and 6, and so I've got pi on 6, and then I've got nearly pi, but short 1/6, so that would be 5 pi and 6. So I go once around the circle, but I have to go from 0 to 3 pi. So I have to go around once plus another half time round. So I've gone around once and I've got 2 pi, so this will be 2 pi plus pi on 6, so that's 2 1/6, which is 13 pi on 6. And then, or I'm just adding 2 pi onto each of these, okay? So I go around, so there's my, I've gone around once, I've got these two, now I'm adding 2 pi onto this to get that. So 2 pi plus, this was 5 pi and 6, so 2 5/6, 2 pi plus 5 pi and 6, 2 5/6 is 17 pi on 6, okay? And then I would need to divide these all by 3, so you get pi on 18, divide this by 3, 5 pi on 18, this one, divide it by 3, 13 pi on 18, and this one, divide it by 3, 17 pi on 18, and I can see that these all lie between 0 and 1 pi. But they're my positive angle results. I've now got to do my negative angle results. I might just put them ones in another colour. Might do those in red. So, just drawing that on this diagram. Again, I've got pi and 6, quadrants 1 and 2. So, but for the negative, so now I have to go from 0 to negative 3 pi. So starting from here, you've got to go backwards. So that's negative pi, negative, this is negative 1 pi, so negative 1 1/6. Now that would be negative 7 pi on 6, because 6 pi on 6 is 1. So negative pi, so negative 1 minus a sixth, so that's negative 1 1/6. This angle all the way around here is almost negative 2 pi plus 1/6, so it's negative 2 plus 1/6 is negative 1 5/6, which is negative 11 pi on 6, okay? So what you don't do is just put negatives on these, because you've got to get around to the third quadrant. Well, it's actually quadrant 2, but it's the third quadrant that you're getting to, so that's the first, second, third. So whereas before you were hitting these values straight away, okay? So we've got negative 1 1/6, negative 2 plus 1/6. We've got to keep going around, so that's negative 2 pi, and so add, but if I go, look, negative 2 pi, This is negative 3 pi, so I don't do these ones again, because watching, one full turn is 2 pi. So I've got pi, 2 pi, this will be negative 3 pi if I'm going backwards. Negative pi, negative 2 pi, negative 3 pi. So I don't count these again. So again, just dividing these by 3 to get x. Oops, so divide, get over 18. And this one will be negative 11 pi on 18. And we can see that those results lie between 0 and negative 3 pi as well. The next one here, solving this. Now this is a combination shift. This isn't just, you know, tripling or doubling. So we tripled. We had to do a triple domain here. We've actually got to double the domain and do a sideways shift. So let's have a look at that. So let's look at our domain first. So we're supposed to solve from negative pi through to pi. So that's solve for negative pi through to pi. That is the question. However, we've got 2x, so let's do a 2x. So you would have to double all these. But then we've got 2x plus pi on 3. So our final domain will be to double them all, which we did, and then add pi on 3 onto each of those. So that's 2 1/3. 2 1/3 is 7 pi on 3. And this is negative 2 plus, because we're adding a third, negative 2 plus a third is negative 1 2/3, negative 5 pi on 3. Okay, so that's the new domain there. Okay, so let's start. First we'll move this 2, divide through by 2. We've got cos of 2x plus pi on 3 is a half. And again, same step. Step 1, the acute angle 2x plus pi on 3. So first step is to always get that domain correct. So we say cos of what is a half? And it's cos of 60. 60 is 180 on 3. And step 2 is your quadrants. This time it's positive. Cos is positive in quadrants 1 and 4. So we do our sketch. We've got quadrant 1 and we've got quadrant 4. And then step 3 is to write out your solutions. So therefore, the solution for 2x plus pi on 3 is... Okay, so we've got to go... What we'll do, let's start writing our solutions. So we're going from negative 5 pi on 3 through to 7 pi on 3. Okay, so that is more than twice around. So what we're going to do, let's just put our solutions. So we've got, first one would be, let's do our positive angles first. Okay, so we're going from 0 to 7 pi on 3. So from 0, pi, 2 pi. So let's go. We've got pi on 3 is my first one. So keep coming around. This is 2 pi minus pi on 3. So that's 2 minus a third is 1 2/3, which is 5 pi on 3. And so we've gone once around, and this is 2 plus another third. 2 1/3 is 7 pi on 3. So that one actually fits in the boundary. And now let's go back in the negative direction. I've got negative pi on 3. So I've got to go up to negative 5 pi on 3. So I've got negative pi on 3, that fits in. So I'm going from 0 to almost negative 2 pi. And then this one would be negative 2 pi plus pi on 3. That's negative 2 plus a third. That's negative 1 2/3. That's actually on the border as well. That's actually right there. Okay, if you're going backwards. So I've got negative 5 pi on 3. So now they all fit within from 0 to negative 5 pi on 3 and from 0 to 7 pi on 3. But as I said before, if you miss it, don't worry too much, because as long as your final answer is between negative pi and pi, you can cross off the ones that are not relevant or do not fit. So next thing I need to do is subtract pi on 3 from each of those, and I would get 0. 5 pi on 3 minus pi on 3 is 4 pi on 3. Subtracting pi on 3 here, I'll get 6 pi on 3, or 2 pi. Subtracting pi on 3 from this one, I'll get negative 2 pi, on 3. And subtracting pi on 3 here, I'll get negative 6 pi on 3, or negative 2 pi. Now, we just divide by 2. So dividing by 2, 0 divided by 2 is 0. Dividing this by 2, I get 4 pi on 6, or 2 pi on 3. Dividing this by 2, I get pi. Dividing this by 2, I get negative pi on 3. And dividing this by 2, I get negative pi. And so therefore, my solutions are negative pi on 3, 0, 2 pi on 3, and pi. Look, you can write them out in order. Notice they all lie between negative pi and positive pi. So you could write them out again in order if you want. Okay? And by writing them out in order, I suppose you can see that they do lie between negative pi all the way through to pi. Okay, so just be careful there. You do get ones lying on the borders of the domain. All right? And now, just do this one here. 8c from the examples. So first thing, let's just divide through by 2. And we also need to fix up our domain. So the domain is from negative pi to pi for x. However, we've got 2x minus pi on 12, so we need to multiply through by 2. So we get negative 2 pi is less than or equal to 2x, which is less than or equal to 2 pi. And then we need to subtract pi on 12 from each of these values. So 2 minus 1/12 is 1 11/12, so to 23 pi on 12. And negative 2 plus 1/12 is negative 1 11/12, which is negative 23 pi on 12. So, sorry about that, made a mistake there. So, it's negative 2 minus 1/12, which is negative 2 and 1/12, which is negative 25 pi on 12. So, just fix that, please. Just be careful, because you're doing negative 2 minus a 12th. So, you're going back further. But this is 2 minus a 12th, all right? So, now that we've got our domain correct, all right, let's just follow our 3 steps. So, step 1 is my acute angle 2x minus pi on 12. So it's sine of that is root 3 on 2. Don't worry about the negative, it's just the quadrants. So sine of what is root 3 on 2? It's sine of 60. 60 is pi on 3. My next step is my quadrants. Sine is negative in quadrants 3 and 4. Drawing your diagram in quadrants 3 and 4 with pi on 3. And we're going almost from 0 to 2 pi. We're just short of 2 pi. Okay, so let's start with our solutions. Step 3, my solutions. So 2x minus pi on 12 is. So remember, we're going from 0 to just under 2 pi. So we're just doing a revolution basically and stopping short a little bit. So my first solution is the pi plus pi on 3, so that's 1 1/3, that's 4 pi on 3. My second solution is 2 minus 1/3, that's 1 2/3, which is 5 pi on 3. Okay, now that is 1 2/3 is definitely less than 1 and 11/12, so that fits. And if you're not sure, don't worry, you should be able to see if it fits between 0 and pi at the end. And now we need our negative one, so we've got to go from 0 to more than negative 2 pi. So first one would be negative pi on 3. So I would have negative pi on 3. And then this is negative 2/3 pi, negative 2 pi on 3. Now, let's say I've got negative 2 pi and this. Let's say you don't realize this is actually out. It's too far. So let's say I've got, I've got negative pi on 3, negative 2 pi on 3. I've got negative 2 pi. This is negative 2 1/3. Negative 7 pi on 3. But I'm telling you this one is actually out. But let's say you didn't realize it. Just keep it there for now. So we're going to add pi on 12 to each of these. So 2x is, so adding pi on 12 to that. So that's 1 1/3 plus 1/12. You might want to get your calculator out. Don't put the pi's in. So you just do 4 on 3 plus 1/12. So you get 17 pi on 12. Then we want 5 on 3 plus a 12th. I'm just working them out here. You would get So times this by 4 over 4. 20 plus 1, 21 pi on 12. Got negative a third plus 1/12, and times that by 4, negative 4, that's negative 3 pi on 12, which is negative pi on 4. And then I've got negative 2/3 plus 1/12, times by 4, that's negative 8, negative 7 pi on 12. And if I added to this negative 7 on 3 plus 1/12 times in negative 28, negative 27. Now this is one actually is not in. But let's say you didn't realize it and you kept doing that, right? So then we divide by 2. So we've got 17 pi on 24. Yes, that's between. So remember, we're supposed to go between negative pi and pi. So from 0 to pi and 0 to negative pi, that fits. Dividing this by 2, I get 21 pi on 24. Yes, that's less than 1 pi. Then I divide this by 2 and I get negative pi on 8, which is negative 1/8 pi, and that fits. That's between 0 and negative pi. And this one I get negative 7 pi on 24. That definitely fits. That's less than negative pi. But if I look at this one, I get negative 27 pi on 24, and that is more than negative pi, so this is out. It's too big. It's more than negative pi. It's more negative than that. So that's why these, you can cross them all out. That is not a solution. Okay, so your solutions are those 4. Okay, and if you want, you can write them in order. Okay. Just 2 more examples. We've got example 9. Okay, so 9a, solve from 0 to 2 pi. Again, just same steps. Sine of x on 2 minus pi on 3 equals 1 on root 2. So we're dividing by the root 2. So my domain is for 0 to 2 pi, but we have to build this up. So first, let's just divide by 2. So dividing each of those by 2, you get from 0 to pi, and then I've got to subtract pi on 3 from each of these. So I'm going from negative pi on 3 and 1 minus a third up to 2 pi on 3. So my solutions are only going to be, when I do my diagram, only from negative 60 up to 120 degrees. Okay, so let's just follow our steps. Step 1, the acute angle x on 2 minus pi on 3. So sine of what is 1 on root 2? Well, it's 45 degrees, which is pi on 4. And my quadrants are quadrants 1 and 2 is where sine is positive. Okay, so I want quadrants 1 and 2 only with 45 degrees in them. Okay, so just sketching that out. So therefore, that was step 2. Now my step 3 is my solutions. So x on 2 minus pi on 3 is, so my quadrant 1 result is pi on 4. That's good. That definitely lies between negative 60 and 120. Now, you're actually supposed to really start at negative 60. So if I say negative 60 is about here, and I'm going through to 120. See, this is 120 degrees. So starting from here at negative pi on 3, I do get that solution, then I get this one. Now this is 3/4 pi. Because if this is 0, this is 1 pi, 1 minus a quarter is 3/4. Now we know that 3/4 is greater than 2/3. Okay, that's 120. This is 135, so this is too big, so this is going to be out. But let's say you didn't realize it. You will pick it up later. Now, what I've got to do here, I don't multiply through by 2. I've got to, this is just like a, pi on 4 is like a number, it's got no x. So you add pi on 3 to each of these first. Now let's say I didn't realize that the 3 pi on 4 was out, so I add pi on 3 to it. Okay? So you can actually pick it up. If you don't pick it up here, you could pick it up at the next step where your x on 2 has to be between 0 and pi, and let's see what we get. So a quarter plus a third, that's 7 pi on 12. That's definitely between 0 and pi. And here I've got 9 plus 4. I've got 13 pi on 12. See, I can see that that is bigger than pi. Because see, here I'm working with x on 2. Because we added pi on 3. So I can see that this is out as well. But let's say you still didn't see it. So when you now, to work out x, you need to multiply through by 2. So multiplying by 2, you get 14 pi on 12. And if you multiply this by 2, you get 26 pi on 12. Now if I simplify those, 14 on 12, that's 7 pi on 6. Yes, that is definitely between 0 and 2 pi. It's 1 and 1/6. But this one, if I simplify that, I get 13 pi on 6. Now that is too big. That's bigger than 2 because 12 pi on 6 is 2. So that's too big. So here, 3 places we've seen that that solution is not correct. So therefore, the only solution is that x is 7 pi on 6. Okay? So like I said, if you can't see it here, you might see it on the next row, or you can wait till the end and you can just say this is not a solution. Okay? All right, now for just one more of those. So solve for x lying between -3 pi and 3 pi. So again, first thing you need to do is get your domain sorted out. Here we're working with x on 3 first. Don't worry about the pi on 6, just do your x on 3 first. And it means to divide each of these by 3, and you get from -pi through to pi. And now we're adding pi on 6 to each of these. So -1 pi, or -1 plus pi on pi plus pi on 6, that's -5 pi on 6, because it's -1 plus a sixth is -5/6, and this is 1 plus 1/6, which is 7 pi on 6. So therefore, your new domain is from -5 pi on 6 to 7 pi on 6. Again, our 3 steps. Step 1 is your acute angle, x on 3 plus pi on 6. So we say tan of what is 1? We know it's tan of 45, which is pi on 4. Our next step is our quadrant. So tan is, we can see, positive in quadrants 1 and 3. Our next step is to draw it and to start writing out our solutions. So our solutions for x on 3 plus pi on 6, so sketching quadrants 1 and 3. Okay, now you have to start from -5 pi on 6. Now, actually, I'll do the positive solutions first. So it's from 0 to pi. And then I'll do a graph, a drawing for my negative angles. Okay, so let's do from 0 to 7 pi on 6, which is a bit more than 1 pi. So my first solution would be pi on 4. And my second one, well, you might think it's pi plus pi on 4, that's 1 1/4, 5 pi on 4. But is 1 1/4 bigger than 1 1/6? It is, because 1/6 is smaller than 1/4. But look, it is out, but I'm just going to leave it there for a moment. Then I've got my negative angles. Remember, we are in quadrants 1 and 3. So my first solution, I've got to go from 0 to -5 pi on 6. So this is definitely a solution. So that's -3/4. And if I keep going, that's too big. I only want to go to less than -pi. -pi is there, so no point going more than -pi. Okay? Now remember, this one actually is not a solution, but I'll just cross it out for now, but you could leave it. Well, yeah, what we're going to do is we've got those, so we need to get the x on its own. So we're going to subtract pi on 6 from each of these. So pi on 4 minus pi on 6, 5 pi on 4 minus pi on 6, and -3 pi on 4 minus pi on 6. And so working those all out, you'd get pi on 12, 13 pi on 12. Sorry, I just got to fix this one up. -18 minus 4, -22, I think. -22 pi on 12. Timesing this by 3, sorry, and that by 2. I'd get -9 minus 2, -11, sorry, -11 pi on 12. Okay. And then now just multiplying each. So they're my solutions. And look, I know that this one's not right. I could cross it out. You can see for x on 3 that your values are supposed to be between negative pi and pi. And this one is larger than pi, so I could cross that out if I didn't do it up there. This is still less than negative pi. And now multiplying through each of these by 3, I would get 3 pi on 12. If I did not realize this was not a solution, I'd get 39 pi on 12. And this last one would be negative 33 pi on 12. And now, sorry, just fixing that one up. Okay, so they're my solutions. Now, 3 pi and 12 is pi and 4. 39 pi and 12, that's bigger than 3 pi, so that's out, okay? And this is less than negative 3 pi, because that would have to be negative 36 pi on 12. So that other solution, but I can divide these by 3, and I would get negative 11 pi on 4. Okay, so they are my only two solutions, pi on 4 and negative 11 pi on 4. Here's just one more, okay? Again, just be careful with this one. Be very careful because of this 2 here at the front. First, we will divide by 2 to get rid of this 2. What I would do here if I were you, I would, very tricky, I would multiply the 2 by each of those to get 2x on 4 or just x on 2. And this is 2 pi on 6, which is pi on 3. So I would do that one like that. Just be very careful because it's 2 times that and 2 times that. So please be careful with those. And once you've done that, then it should be fine. So remember, it's from negative 2 pi to 2 pi for x. But we've got x on 2, so dividing each of those by 2, we'll be solving from negative pi to pi. And then we've also got to subtract pi on 3, or a third pi from each of those. So 1 minus a third is 2/3. And negative 1 minus a third is negative 1 1/3, which is negative 4 pi on 3. Okay? So now you can start with your solution. So step 1 is your acute angle, x on 2 minus pi on 3. So cos of what is root 3 on 2? Now that's cos of 30, which is pi on 6. And step 2 is your quadrant. So cos is positive in this case. In quadrants 1 and 4. So again, doing your sketch for quadrants 1 and 4. Okay? And you can now do your solutions. Be careful, we're starting from negative 4 pi on 3 all the way up to 2 pi on 3. So, look, I can indicate where that is on that graph. But let's do our positive solutions first. So, x on 2 minus pi on 3. That's what we've got here, is. So, we're going to go from 0 to 2 pi on 3. So, this would be 0, here's pi. So, this would definitely be a solution, pi on 6. And then we've got to stop because 2 pi on 3 is here, and then we've got to stop and go from 0 to negative 4 pi on 3. So my other solution would be this, negative pi on 6. Now this is negative pi, negative 4 pi on 3 would be negative 1 1/3 pi, which is about there. So they're the only two that you've got. Now you need to add pi on 3 to each of these. So we've got pi on 6 plus pi on 3. And we've got negative pi on 6 plus pi on 3. And just working those out, you've got 1/6 plus 2/6, a 6 plus a third, making common denominator. You'd get 3 pi on 6, and here making common denominator, you get negative pi plus 2 pi, which is pi on 6. And we know that they are just pi on, so that's really pi on 2 and pi on 6 for x on 2. And now just multiplying your answers by 2, you would get 2 pi on 2, which is pi, and 2 pi on 6, which is pi on 3. Okay? And they're your two solutions. That's it for the examples.